Hello, for this problem, we've got a complex shape. So we're asked to find the x and y coordinates of the centroid of the shape shown below. So we've got kind of a rectangular section with a circular cutout, and there's this triangular section over here. So we're going to use the method of composite parts to find the centroid, the x and y coordinates of those in terms of our coordinate system. So I've defined, this is an important part of each problem, y-axis and the x-axis, making this point down here in the corner our origin point. So for each of these, we need to come up with a table. So we're going to need to break this down into parts, and right up front, let's break it down into 3 parts. We're going to create part 1 is going to be this rectangle here. It's 4 inches wide by 3 inches tall. Part 2 is going to be the circular cutout. So I've got a circular hole. It's 2 inches in diameter. It's 2 inches this way, 1.5 inches this way. That's the center. So it's got the same center as the rectangular point there, or the rectangular area there. And then area 3 is this triangular area over here. So I know that based on this being 4, this being 8, this is going to be 4 inches wide and then 3 inches tall. So I need to create a table, and I'm going to find, for each of these 3 shapes, I'm going to find the area, I'm going to find the x-coordinate for the centroid of that shape, and I'm going to find the y-coordinate for the centroid of that shape. So let's go ahead and create our table. So I need the shape, the area, the x-coordinate for the centroid, and the y-coordinate for the centroid. And so I've got shape 1, 2, and 3. And creating this table is kind of the centerpiece of anytime we are going to use the method of composite parts. So, for shape 1, let's go back to our problem. We've got a rectangular area. So for our rectangular area, it's 4 inches wide by 3 inches tall. Our area is going to be 12 square inches. So we end up with 12 inches squared right there. All right, next up is my circle. So this is a cutout. That means I'm going to count it as a negative area. So it's going to have a negative area, and the area of that circle is going to be pi r squared. If diameter is 2 inches, my radius is 1 inch. So pi times 1 squared, that gives me roughly 3.14 square inches. And again, it's going to be negative because it's a cutout. So finally, area 3, let's look at the area of that. It's a triangle. So 1/2 base times height. The base from here to here, that's going to be 4 inches. And then the height is going to be 3 inches. So for area 3, 1/2 base times height gives me 6 square inches there. All right, next up I need to find the centroid for each of these shapes. So for this, I'm going to go to the tables, and online you can see the link to the tables there. But I've written down some of the important ones here. So taking from that table, I've got 3 shapes. I've got my rectangle, my right triangle, and my circle. And each one of these, I've got some information on where the centroid is. So the first one is the rectangle. The centroid, the geometric center of this shape, is going to be half of the way across and half of the way up. That kind of makes sense. So my base is going to be 4 inches in my diagram over there. So 1/2 of my base is going to be 2 inches. And my height is going to be 3 inches on the diagram over here. So my height, 1/2 of my height is going to be 1.5 inches. And both of these are measured from, I've got my origin point here, so I go over 2 inches, up 1.5 inches, and that's the center of my rectangle. So easy enough. x bar is going to be 2 inches, and y bar is going to be 1.5 inches. Alright, so next we have the circle. And I really didn't draw in any dimensions for this circle, because usually we measure everything with respect to the center of the circle. And the center of the circle is the centroid of a circle. So I just need to locate the center of this circle over here. And so going from my origin point right here, the center of the circle, I know it's just kind of simply defined on the graph. It's 2 inches this way and 1.5 inches up. So I end up with the same values here. The center of the circle is 2 inches over and 1.5 inches up. Alright, finally I need to find the centroid of my triangle. So for my triangle, the centroid is going to be somewhere over here. And looking at the table, I have this. So I know that from the right angle, like right there, if I go 1/3 of the way, the length of the base, from that side, 1/3 of the height of the triangle up, I'm going to end up at the centroid. So if I look over here at shape 3, I know I want to go from the right angle, which is going to be right here. I go 1/3 of the base, so the base is 4 inches, so 1/3 of that is going to be 4/3. So I need to go over 4/3. But I'm also defining everything from over here. So I need to go, before I even get to the triangle, I need to go 4 inches over, and then an extra 4/3 this way. So 4 inches plus 4/3 inches is going to give me a value of 5.33 inches. That means the x-coordinate for the centroid of this triangle is 5.33 inches over, somewhere around here or so. Alright, so now I need to look at the height of my centroid. And so going from the right angle side, if I go 1/3 of the height up, I end up at the centroid. So looking here, if I going from the right triangle side, if I go 1/3 of the way up towards the point, I'm going to end up at my centroid. So 1/3 of 3 inches, which is the height, is going to give me 1 inch, which is the height of my centroid there. Alright, so once I filled in this graph, or once I filled in this table, this is most of the work that I need to do. Now I just need to perform the calculations. So x bar, we call this x bar t, it's the x-coordinate for the overall centroid of the shape, is going to be equal to the sum of area times x bars over the sum of the areas. So this is going to be area times x bar 1, so 12 times 2, plus, I go to the next line, negative 3.14 times 2, plus I go to the third line, 6 times 5.33. And divide that whole thing by the overall area. So 12 minus 3.14 plus 6. Alright, now I've got all the numbers plugged in, and if I solve this equation, I should end up with a value of 3.34 inches. Alright, next we want to go ahead and do the y values. So y bar t, this is the y coordinate, is going to be the area 1 times y bar 1 plus area 2 times y bar 2 plus area 3 times y bar 3. So 12 times 1.5 plus negative 3.14 times 1.5 plus 6 times 1. And I could, again, I'm going to divide that by the total area, so 12 minus 3.14 plus 6. And if I do all of this math, I should end up with about 1.29 inches. Over here, this is my x bar, and this is my y bar total. So if I go back to my diagram, my x bar total, I'd have to go over about 3.34 inches, somewhere about this far, and I'd have to go up 1.29 inches, so not quite halfway. My centroid is going to be somewhere there. And again, I'm going over 3.34 and up 1.29. So with that, we've found our centroid and we've solved our problem. Thank you for watching, and I hope to see you again.